Welcome everyone to today's webinar, MQTT versus OPC UA, the Industrial Data Showdown. We're thrilled as always to have you here. I figured we'd start with some introductions. Who are we? Why should you care? My name is Kristopher Sandoval. I'm the Developer Relations Advocate at Flowfuse. If you've watched any of our YouTube stuff or if you've come to any webinars, then you're probably familiar with who I am. I've been in this space for a very long time. My background is actually pretty heavily in APIs and pretty heavily in security. So obviously this is a topic that is near and dear to my heart. I am joined today by Kudzai. Kudzai, you want to go ahead and introduce yourself and talk a little bit about who you are?
Absolutely. Thanks, Kristopher, and welcome everyone to this webinar. So my name is Kudzai Manditereza. I'm a Senior Industrial Solutions Advocate at HiveMQ, and I also run an independent media and education Industry Forward.tv, which is a YouTube channel, podcast, and also a newsletter. You might have seen some of the videos that I do. I've got a background in industrial system integration, mostly on the PLC programming side of things. I do a lot of, I've done a lot of education around the topic of OPC UA, MQTT. So this is a topic that is near and dear to me. So I'm really looking forward to unpacking that with all of you here today. Thank you.
So to give you a little bit of an understanding of what we're going to be talking about today, just set the agenda. The first thing we're going to do is give you a little bit of understanding about the build environment. So all of what we say today is not just general advice. This is actual practical advice and comes with a demo. So I'll give you an understanding of the environment that we're working in so you can start to see how these things interact. And then we'll start right in with the argument for MQTT that is backed by Kudzai. And then I'll go ahead and make the argument for OPC UA. And then we'll talk a little bit about the middle ground and then some forward thinking, what it means when you have this middle ground and what it means to build in this reality. And then we will jump directly into our Q&A. So the first thing I want to start with is the build environment. So this build environment, what we're going to be showing today in terms of practical application, this is our demo that we launched at Hannover Messe. And the idea here is that this is a multi-site factory. It is a massive factory flow. And it generates, ultimately, its output is some CRISPR gene therapy. If anyone is not familiar with that, it is a customized gene therapy that can be deployed for cancer treatment or any sort of degenerative diseases. Lots of different things that are affected by genes. There are therapies that can be genetically targeted. And so in order to do this, we need a lot of sort of precipitating devices. We have things that are, specific centrifuges that are customized and calibrated in a very specific way. We have, the bioreactors and the gene therapy side of things. We have a lot of complex parts that are all interacting with each other to do this ultimate thing. And because of that, we have a production flow that needs to do a lot of intermediary steps. The three core steps really are creating memory modules that have custom firmware, so that things that can drive memory sequencing and genetic sequencing. And then centrifuges that, as I said, have a very clear specification because they need to be within certain tolerances to get you to your therapy, but not beyond that to destroy genetic material. And then finally, the actual deployment of the centrifuge as part of the genetic therapy factory. And so getting into what this looks like in practicality, what we really have is three factory sites and sort of an intermediary category. We have the San Francisco site, which is generating RAM and ROM chips, literally sawing the chips and then installing firmware where necessary, testing in other places, and then ultimately deploying that as a critical component. Then we have the Funabashi site, which is in Japan, that does all the centrifuge assembly and all the testing and just has, all the component pieces there. And then we ship everything out to Hanover, where we do the actual gene therapy itself, which has temperature regulated bioreactors, cryo packaging, all the things you would expect. All of this is mediated by sort of a middle layer, which is the transit layer. This is intrafactory routing, and that comes obviously with a high need for chain of custody, a high need for regulatory pieces, frameworks and appliances, and a lot of control systems. And just to give you sort of a visual representation of what that looks like, this is essentially what we're talking about. We have San Francisco to Funabashi to Hanover, and everything in between is mediated. So it's quite a complex environment. I will say that this sort of data space This is somewhere around 4,000, almost 4,500-ish topics that are constantly pushing. I think right now we're set on like a 1 second generation cycle. So every 1 second we're getting 4.5K topics. So a lot of data. So to begin this conversation, we'll go ahead and start with the argument for MQTT. I'll go ahead and hand over to Kudzai.
Thank you, Kristopher. All right, so I'll start with an argument for MQTT and kind of like just to set the foundation for our discussion here. I'll start with kind of like a quick primer of exactly what we're going to be focusing on. So I'm going to be looking at this from 4 key perspectives, just to make it more relevant to kind of like the audience that we have here. So we've got quite a varied set of professionals on this audience. So I'm going to look at it first from an OT, operations intelligence, basically how to sort of like make data accessible to solve problems on the shop floor. Looking at the MQTT from that perspective, and then once we do that, we're also going to look at OT IT integration architecture, because once you solve those local problems, in many cases you want to make that data available for integration into like your IT, central IT or plant IT or whatever integration you want to perform. So we're going to look at it from that perspective as well. And then another good thing to look at it is from the cybersecurity perspective, OT security, on exactly how these two protocols actually play to that. And then lastly, we're going to look at enterprise scalability, because that's kind of like a huge part of what really determines what to pick for what function, because in many cases you want to be able to scale that connectivity infrastructure across different plants and different geographical areas, as Kristopher has already spoken about this environment that we have here for the demo. So yeah, let's get started. So first and foremost, just kind of like do a quick primer for those of you who need maybe a refresher on exactly what the key differences between these two protocols are. So the first one is OPC UA, which is based on a request response pattern of communication. So this is your point-to-point synchronous communication, whereby you've got a client and a server. So your client requests, sends a request, and then a server sends a response. So as you can see, this is kind of like a direct connection between two systems. And then on the other hand, we've got MQTT-based publish, subscribe, decoupled architecture, which is event-driven. So what that means is that you've got, instead of having two sort of like participants directly communicate to each other in a request response fashion, you've got sort of like an intermediator or a broker that does the relaying of information across the different participants. So obviously that allows you to have like a one-to-many or many-to-one kind of communication fashion. So before we kind of like go more into details, I want to kind of like make something clear also, because someone would say, well, you actually have OPC UA over MQTT. So just kind of like to clear that that's exactly the point, right? So OPC UA over MQTT is OPC UA semantics over MQTT. MQTT is still that transport that provide that publish, subscribe mechanism of communication. So we're not comparing these two. OPC UA, I'm talking about the request response OPC UA using OPC UA transport, not OPC UA using MQTT transport. And then again, event driven, again, some would argue that actually you can actually push events from an OPC UA server. So again, still we need to sort of like maintain that dedicated connection between two participants. It's not a pub sub event driven kind of fashion. So just to make that clear before we proceed. All right, so because of that, actually, these two protocols are going to fall into these two different camps. So first and foremost, you've got your OPC UA, being responsible for more your closed loop process control. So if you are in a work cell, you're controlling, whether it's robotic arms or you're, opening valves and things like that. This kind of like really, it's not even an argument that you need to be using something that has got this synchronous, communication like OPC UA, or you've got like an HMI that you need to push things around, or you've got your SCADA system where you need to have this direct connectivity between your control or layer and the actual equipment and devices. You need to have that direct, communication. So obviously A is really good for that data modeling aspect because it actually allows you to model these objects in the shop floor in a way that it can actually be understood by, other consumers of that OPC UA data, so that you've got that interoperability. So that's going to be that layer where you're going to see OPC UA mostly as we proceed with the discussion. And then MQTT, when you then want to distribute that data, right, for whatever use cases, analytics, integration, and many more. This is where you start to want to have that flexibility that MQTT provides, mainly because of that decoupled publish subscribe communication pattern. So yeah, let's go to the next one. Okay, so this you may have seen if you have kind of like been in heard about this topic here. This may be familiar to you, this idea that with OPC UA you've got this point-to-point integration. So as you can see, what we have there at the bottom are what would typically represent, say, a work cell or a specific manufacturing operation, where within it you've got your your reactors, you've got your robotic arms, whatever is happening there. You've got this network of communication that is happening using OPC UA. And typically this is a situation where you've got a limited set of devices that you want to connect, right? So in a work cell, you really have like a limited set of devices that you want to be able to communicate, right? So this kind of like becomes that idea that you've got OPC UA in all these different work cells. But when it comes to then wanting to make that data available to different stakeholders within the OT environment that want to access the data to be able to. So actually, if we could just go back a bit, Kristopher, before that one, where if you want to then serve that data to different stakeholders that need that data to solve specific use cases, right? As you can see, we've got different use cases there, OEE, yield, downtime, and energy. So first of all, for your OEE, you may need things like equipment state, good count cycles. So again, for a reliability engineer will may need again equipment state, right? And then the yield or the process engineer may need again the good count to calculate the yield. So what you'll notice here is that even though it is the same piece of data that you're actually collecting from all these different systems, you have to do it more than once. You have to collect it more than once. So basically, you are repeating that connectivity infrastructure, which then ends up creating this spaghetti architecture, which is hard to maintain because now you've got each and every use case or each and every application connecting directly to a certain OPC UA node ID, OPC UA server endpoint, and so on. So you're kind of like creating this, which is hard to scale and actually makes that digitalization slower because now you need to go through, if you need to bring in a system integrator or a specialist who knows how to unlock that data, whether it's in an MES system, whether it's in an actual TLC. In many cases, it's actually an expensive process to get people to actually set this up. So this is kind of like the big disadvantage that you get from that. So now when we look at the MQTT side of things, so effectively what MQTT helps you do is really, first and foremost, I mean, if you have heard this argument about OPC UA and MQTT, you may have heard things around MQTT being lightweight, report by exception. Yes, while that is, a big advantage, what I would say is primarily the biggest, differentiator is just this ability to decouple, communications, right? Because as you can see, we're moved from different, web of connections that you actually need to maintain to having that one central piece act as the, source of your data. So for example, your process engineer that needs good count to calculate yield only needs to connect to the MQTT broker to get that. And then that same piece of data can actually be reused by, your your OEE calculator that needs again to connect to the same data broker. So effectively, what you're doing here is you're actually, setting up your connectivity infrastructure once and then reusing that data. And second thing about it, that this is bandwidth efficient, right? Because if you've got a request response kind of communication that you need to set up, which comes OPC UA, it means that you're always polling all of these different servers to try to get data out of it. So obviously that introduces sort of like a burden on your bandwidth because you need to maintain these connections. But here you actually data that is being pushed from the edge into this data broker, and all these different parties that need to get the data, they need to simply subscribe to receive that information. So this is, again, makes it really easy to move from one use case to use case. Anyone who actually comes up with a problem that they need to solve. So if I've got a problem that I need to solve, maybe I need to monitor the tank level, and I need to maybe calculate the average or temperature over a day or two. I'm not having to go into and look all of the OPC UA addresses, look at the different data point. I'm going to the broker, getting the data that I need from there, and simply calculating it and reusing it. And it's kind of like other thing that helps you with it removes that complexity, because we spoke about this idea that OPC UA allows you to describe object using an information model. And that kind of like adds a bit of complexity, to how you can actually access and use data, because you have to understand the information model first and foremost. So you have to understand, the protocol itself for you to effectively use it, and also the tools that are available for you to be able to use that is a bit limited. So with MQTT, what actually made it even more popular is this idea that you can actually find tools that anyone can actually use and subscribe to a topic, get the data you need, and then start to push it up. So as you can see here, you can actually do the conversion, and this is where again we need to emphasize that OPC UA still has that role, at least from my perspective as an MQTT advocate, still has that role in your level from level 0 to level 2. And then once you want to distribute that data, this is where you can then put a gateway like Node-RED that does that OPC UA conversion to MQTT. You're going to see a cool demo of exactly how an OPC UA node can be used to actually do that conversion and extract all of this data and push it into MQTT, and then distribute the data to all the different participants. Right? If we go to the next one, so once you have unlocked data and actually made it accessible to all the different users within your OT environment that want to solve specific problem using the data, in many cases the IT team wants to get that access, and the IT team in many cases they don't have that one point that they could actually go to get the data that they need for business solutions. So in many cases they need to go to a historian, they need to go to an MES, they need to go to this data, they need to go to this PLC. They actually need to connect to all these different services to get the data that they need. And in many cases, this is data that is not ready to be used in things like your analytics platforms and things like that. So the MQTT broker, once you have it in your shop floor, that primarily put to solve OT problems, also becomes an integration point for your IT integration. So what that means is that you can then bridge that data to a central server. And the big advantage of that is that within the central server, this is where you can then start to apply governance, because if it's in the OT, it's mostly OT users who are actually using it to solve their own specific problems. But once you want to have data that you can rely upon to make business decisions, you want to be able to apply some form of governance, which could be schema validation, and things like that. So that broker that sits at an IT level, collecting data from all this, bridging all of this data from different sites. In this case, we've got your Hanover site pushing that data to central IT, and then enforcing that. So as you can see here, we've got a Node-RED that is doing the conversion from your OT systems, pushing into an MQTT. And then on the other end, you could also have a Node-RED instance that is actually pulling data from your ERP system, contextualizing data, because while I have the arrow going up, you could actually go back down again. So in case you want to send stuff or orchestrate your communication going back down to the shop floor, that becomes that same pipeline. So if you think about the number of servers or services that you need to care about from an IT perspective just to get the data that you need, this will go into hundreds of thousands, at least in my experience for companies that want to do that. That has literally been reduced to that one single endpoint that you need to care about to get all your real-time data. So from there, you can then persist it, into a data store because you still need to have that historical context. Right. So the next one is from an OT or rather a cybersecurity, perspective. So if you have, again, I just spoke about this idea that in many cases you may need to access data from 1,000 services or 100 services which are exposing an OPC UA interface, and what that means is that these are all open pods, right? If you've got an application that is reaching out from IT into OT, then you need to open all these inbound pods to allow access, which effectively increases your attack surface, right? And with MQTT, because with MQTT, you're only required to open an outbound port going into your broker from your OT. Effectively, what a lot of companies do is that they use this as that, data diode, as it were, that sits at level 3.5 in the DMZ, which means that you only need to just open that one outbound port going out to push all of your data out. So which effectively reduces your attack surface from thousands of open ports on your shop floor to only that one port going up into IT. Same again with that perspective going into the IT side of things. Right. And then lastly, on kind of like an enterprise, scalability, what we have done or what we have shown, for a site, let's say your Hanover site, that allows you the ability to be able to, replicate that, to scale that across different sites, because effectively you're using a broker as a gateway to all these different sites. So from the central platform side of things, you don't need to care about what's actually, happening behind that broker. You only need to connect those, to those broker endpoints that are at each site. So in this case, you're getting all of your data from that Hanover site. You've got your data from your San Francisco site, and then also from the data that is in transit. So these are all events that are being published from the shop floor. So whether it's a firmware upgrade, whether it's a part has moved from point A to point B, whether it's a supply chain issue, whether it's a traceability issue, all of these are actually being pushed as events into a central platform that you can then use to do your traceability use cases or AI use cases on that one central platform, because you're able to push everything out from each shop floor to the central data platform. So yeah, that brings us kind of like to a short, introduction of MQTT perspective.
I will start this by saying I agree with everything that was just said about MQTT. Fantastic argument, really, really strong argument. However, there are some considerations. I've seen some questions come up in the chat that actually hits on some of the things I'm about to talk about. So let me quickly, before I dive into the core argument here, I'll give you sort of a sense of the three core needs that we're running into and why the MQTT side of things is not necessarily the best fit for some of what we're trying to do. So the first thing is, the three core needs that we have of this flow is chain of custody, or feedback loop for lack of better terms, bidirectional determinative actions, which is a long phrase. I'll get into what that means in a minute, and then the definition of data semantics. And when you're looking at how this data flows from site to site, you start to see that there's a little bit of qualification as to, we don't just need the data to flow, and we don't just need the connectivity to be connected. We need some additional layer on top of it for very specific use cases. For the San Francisco site, we have things that are sawing extremely expensive materials to make RAM and ROM chips. These are things that, electrical variants, magnetic variants, even SAW variants, these small things, vibration variants, all of this can lead up to massive downstream losses. And so there is this need for making sure that, hey, this material has arrived, it has been cut in this way, the safety trigger has not triggered, and then being able to trigger actions based upon the state of those things. Taking out of the San Francisco site, we now have this huge need for quality control, for material tracking, for transit tracking, these things that require not just a single directional data stream, but a bidirectional data stream, and specifically a bidirectional data stream that informs whoever is working with that stream the entire meta contextual information about that stream, everything about who has shipped this out, why is it shipped out, and what quality, and what quantity, and what format, on which device or which truck, or so forth. And getting into the Funabashi site, you start to see there's sort of an additional layer of complexity. You not only have the assembly sort of standard operating procedures, you need to know exactly how these things are put together, not just for putting together the devices in a typical sort of manufacturing flow, but also for regulatory purposes. Because if something fails down the line, you need to have this long-term chain of custody and this provable sort of chain of materials from one site to the next. That way you can trace back, okay, this lot of gene therapy has reported ineffective and it was on these devices from these sites with this operator, and sort of following that chain all the way back. From that, you now have additional needs coming out of the Funabashi site. You have unit testing, you have shipping safety, you have all these additional pieces that you can report over MQTT, sure. But the additional need for meta-contextual information, the additional need for bidirectional flow of data and command, and then documentation of that bidirectional flow of data and commands, that starts to become something that is a little bit more complex than MQTT can handle just by itself. And we'll get into the specifically OPC UA over MQTT piece that Kudzai mentioned earlier, because that is actually part of this conversation as well. But it just starts to be a much more complex problem than it can be handled than can be handled in a simple way. And then coming into Hanover, finally, you have what is perhaps the most intense factory of these three, right? Because the San Francisco site, like, okay, we're producing RAM and ROM units. Worst case scenario, we could get off the shelf and flash our own firmware and move on from that. Funabashi, centrifuges have to be specifically calibrated. Worst case scenario, we could buy centrifuges and calibrate them ourselves and go through that process. It'll be wildly expensive, but we can do that. If things in the Hanover site fail, and we're doing gene therapy for someone with cancer, it's not like we can just say, oh, it's a little bit more expensive. That person could die. Or, someone who has a degenerative disease could lose progress over the course of months. And so we need a system that is much more concrete and much more reportive and determinative and just more complex. And so getting into the individual pieces here just briefly, in terms of the chain of custody piece, we don't just need to be able to track things. We need to have automated alerts on receipt. And then those alerts need to go back and do something. We need to know lifetime tracking of each unit throughout the entire state in a way that we can't just pass via an MQTT topic. To do this over MQTT, we would need to have an additional topic layer. We'd have to have an additional address space. We'd have to have some sort of permeance of tagging over multiple hops. We'd have to have a very complex system to make that happen. And then in terms of the action tracking that goes on top of that, to be able to track the metadata, for instance, has this been received by whom? Was there an interrupt pattern? And then to be able to track that over time, we need to have a lot of systems that then start to make MQTT, not just MQTT, but MQTT plus some sort of database or plus storage or plus something. And then when you get into that state of MQTT plus, well, then you start arguing, well, why can't we just use OPC UA? Because in many ways, that is functionally what we're talking about. The more complex piece of this, and sort of the classical argument for OPC UA, is this bidirectional determinative actions. Now, I said that earlier and said I'll explain it, so let me explain it now. Bidirectional determinative actions is something has happened, and because this thing has happened within the meta-contextual reality that it happened, we must now trigger an action. A very good example that I'll show you in a little bit is you have a bioreactor, and this bioreactor has a metric, which is the dissolved oxygen in the bioreactor itself as a part per million measurement. Now, if you wanted to say, okay, that does not hit, the standard that we expect, it suggests that the batch has to be held. In the MQTT solution, you would have to have some sort of topic that is being generated that then is determinatively set by some sort of flow or some sort of automation solution that would have to do some math on the fly. And then pending that math would have to trigger that notification or that alert. And then that alert would have to be stored in a historian somewhere. And then that would have to be used as the input of another topic. And you start to see you get this almost like feedback loop that is becoming more complex every time this happens. For one bioreactor, that's fine. That's easy enough. When you have a set of 50 bioreactors, or when you have to do that across the entire site, all of a sudden you're doubling or tripling every single topic set on every single device, and you start talking about all of the efficiency that comes with MQTT starts to sort of not necessarily be as clean. And so that is this whole piece of it. This bidirectional determinative actions, you have to trigger actions based on actions. And often that action is not a delayed action, it's an immediate action. So let's say, we get a shutdown order, our bioreactor has gone out of temp or out of dissolved parts, and we need to shut down that reactor as gracefully as possible and as quickly as possible to stop that PCO or the dissolved oxygen reading. We need to stop that from climbing up. And we need to stop it as quickly as possible and also be able to trigger it back once it's within specifications. That is a much more complex set of things that isn't as neatly handled by MQTT. The last part of this, sorry, let me go back. The last part of this is definition of data semantics. Now, I will say, again, I agree, and you can push some of this over MQTT. What is more complex, though, is the need to have almost hypermedia-like functionality with our data stream itself. Now, anyone who's not familiar with hypermedia, it is this idea that you get some data back from a data point, and it tells you where to find additional information, what the meta contextualization of that information is. It's the sort of thing that, like, when you go on social media, it'll tell you who all of your friends are and then allow you to find their posts and allow you to find, related media. That is the same thing that we're trying to do with this data. We need to have the dissolved parts come up and say, hey, this is out of spec. And also, here's the specification. Also, here's the historical reading. Here's the machine it's coming from. Here's the context of that machine, who's operating it, and then how many times over time this has happened. You can do all of that with MQTT, but you start to add so much complexity on top of it that the argument becomes, okay, well, why are we doing it with MQTT? What's the value of that? And then there's this additional layer, which is the meta contextualization. And the meta contextualization, to be clear, is not the data itself, it's the data about the data. It is the data about all the generation, the reality of where this data has come from. It is a much heavier body of data that is sort of reported by default from OPC UA. In fact, a lot of the complaints that people have about OPC UA is how heavy it is. One of the reasons it is heavy is because it provides all of this in its base form, right? And so the argument is, if you need all of that already, well, why not just use it? So that is the kind of core argument. What I want to give quickly is the actual foundational way this works, because OPC UA is a very complex framework sometimes, or a complex protocol. And I just want to give you a brief understanding. So when you take a look at OPC UA, what is functionally happening is every device is reporting data to the OPC UA server. And it's doing that within a sort of understood framework. OPC UA itself, if anyone's not familiar with what it means, because it's kind of just become a word in and of itself, OPC UA stands for Open Platform Communications Unified Architecture. And it is this idea of having a unified architecture by which, as long as you build everything within this expected architecture and within this expected framework, no matter where it goes, it can be parsed and understood. And so all of these devices are sending this data over. It's attributed by node ID. It'll send that data out. It'll collate. It'll correct. It'll document. All of that goes into the OPC UA server. And then when you want to interact with that data or necessarily interact with the machines that generated the data, you need an OPC UA client. And so this client server relationship allows you not only to get all of the polling in a typical sort of pub sub approach. You can get that poll data. If you set up the client to poll, you can get just constant polling of that data. And then when you want to do something, you don't have to emit on a different topic. You can just send back via that same stream and say, okay, if it's enabled in the OPC UA server, you can send that back and say, I want you to do this. Okay, I want you to turn off. I want you to change state. I want you to record all of your data. You can send that back as a direction to the actual device itself through the server. Which is much more like what you would expect, when you think about the sort of client-server relationship. It is much more in line with sort of the typical way that we interact with these services in the common parlance. So, all of that being said, I will say that OPC UA is what you make of it. And what I mean by that is OPC UA itself is a standard architecture, but it allows you to determine what that standard architecture actually looks like in your environment. So if anyone is familiar with sort of the precursor of OPC UA, there used to be a whole bunch of versions of this protocol approach. Now there is sort of the core model, and then there's all these additional things that you can layer on top. And those additional layers that you can put on top are industry-specific protocols. They're solution-specific implementations. They are the companion information models for things like CNC machines. And so you get both the commonality of how to build this thing, and so that's portable from place to place, but you also get the specificity of saying, okay, I really like this protocol. It's a great way of building our entire framework and architecture, but our site, our shop is mostly CNC machines. Well, good news. There's a framework specifically for that allows you to do a lot more things that, is maybe like it's possible via MQTT, but you have to do the legwork to actually do it. Let's start, Kudzai, with the MQTT side of things. Can you explain a little bit about what we're seeing?
Yes, so absolutely. So what I'm looking at is an MQTT node that is connected to a broker and pulling all of this data, and then this data is actually then used to, whether you're managing a switch or you're kind of like just really debugging the data to see what data is flowing through from there. So it's kind of like what I was explaining, where you are essentially subscribing to that one endpoint and then pulling all of this data that has been put into whatever object it is.
Yeah, and I'll show you all briefly as well the actual broker, what this looks like. So the way that this is all reporting is we have the like base sort of reporting name, which is just factory. That is sort of the root topic. From here, everything is broken out. This factory simulation has each factory as its own sub root, so it's child, for lack of better terms. And then from there, it sort of fans out to a bunch of, in OPC UA terminology, would fan out to a bunch of leafs and then, components. And so looking at something like our Funabashi site, you can get down to the very, very specific that, we had belt encoder, we have a defined schema, a defined description. So you do get a little bit of the metadata that we were talking about. What I will say for the MQTT side of this, and I think this is probably the most impressive part of MQTT for most people, this again is sending over 4,000 topics at once, every second. And Kudzai, if you can speak a little bit to the latency part of it and just the speed part of it, I think for me at least, that's like the strongest argument for MQTT for me.
Yeah, absolutely. And I think maybe a good point to also tie this in is if I can already answer a question by Louis, who's asking, why not use OPC UA server as a central node like, the broker, and have everything connecting as an OPC UA client. Kind of like this, to explain is, in many cases, you'll find that if you've got an OPC UA server, you can connect, a few hundred data points, right? So in many, and of course, this is implementation, dependent, but for the most part, really, there's limit to how much data you can actually get out of an OPC UA server at what speed, right? And when you compare that to, the MQTT, like what Kristopher said, you've got like 1,000 topics with 1,000 data points. But where it actually even, from a HiveMQ perspective, where you can even cluster those brokers, where you can actually handle up to 200 million. Actually, we did a benchmark a couple of years back where we benchmarked it at 200 concurrent connections on an MQTT broker. That's unlimited scale technically, because I don't know of any use case where you actually need to connect that many endpoints. Whereas on the OPC UA side, there's very few that you could actually do. And also, what you're looking at there is for an OPC has got what is called profiles, where it's an OPC UA, but it doesn't mean that anything that speaks OPC UA can actually talk to it, right? So you need to know what profile it supports, and you may not be able to support it. But what you're looking at there from Node-RED is that you're essentially just subscribing to a broker, and they're getting all of this data that you need. So whether the JSON payload, and I think Alan Nipper actually put it nicely some time back when he said the good thing about MQTT is that it doesn't prescribe any payload, and the bad thing about MQTT is that it doesn't prescribe any payload, because OPC actually gives you that semantics data rich. But sometimes you want to be flexible to actually consume this. If you're a data scientist connecting to this, you don't need to actually go through tons and tons of books just to understand OPC UA. You know that you just need to subscribe, get the data, and then do whatever you want to do with it.
Yeah, I will also say one of the cool things about this, this solution is powered by MQTT specifically. When we did this demonstration at Hannover Messe, what I wanted to show was the efficiency by which you could pull this data from MQTT and then to give sort of a top level view. And so when you're looking at what we're actually reporting on right now, all of this is coming over MQTT. And every single second, every single one of these topics is updating and has other contextual data. And so you can do like really simple stuff with it because you're just getting data out of a system. That means that you can do all sorts of dashboarding very, very easy with it. There's not a lot that you have to strip out from it. It is, hey, I want the cold chain temp. Well, that is this topic. It's really easy. It's right there. You're done. You're good to go. Like it's that simple. What I would say about the OPC UA side of things, and this is when we start getting into the sort of other side of this demo, this determinative logic, this bidirectional determinative logic, is not as easy to do with MQTT, and you can start to see like where you're hitting that stop sign. It's really easy to pull for dashboarding. Perfect, I can do that. In this case, I have some logic that is saying, okay, I'm pulling from, funnily enough, MQTT directly. And I'm saying, okay, well, this is reporting out. This is saying, this is the sensor reading that we're getting. I actually want to say, okay, we've detected a pH issue, or we detected a dissolved oxygen issue. And in that case, I want to send back to the actual device and say, hey, you need to stop. You need to pause. You need to pause for this time, for this long. That is something that, again, I would need additional topics. I would need more complex pieces. In OPC UA, I can just implement the client here, which is very simple. This is our certified node for OPC UA, which I definitely think if you're using OPC UA, you should check out our certified nodes. And in this case, I can just go ahead and browse. I can look through everything that I have and say, hey, I really would like this specific device to be able to receive commands from me. And so I'll look through my factories and I'll say, okay, Hanover, on the gene editing side, I want specifically bioreactor 2, and I want to write specifically to batch hold. And based upon some sort of detection, I want to trigger an action. And that can be really anything. All of this can now be determinative by the data that's coming through. I can trigger things like state mapping. I can inform other machines. If the batch hold hits true, what I'm doing is essentially taking this, writing back to OPC UA, and then there's automation on all of the other devices that are connected via OPC UA to say, okay, this is the engine for the bioreactor is on hold, which means also do a temp hold and also do an RPM hold and also increase the polling for RPM so that as we get to slower RPM, we might get a little unstable, start detecting that. There's a lot of automated things that you can do that while you can technically do it on MQTT by itself, we need to have a little bit more sort of complex programmatic reaction. And that kind of takes us to the last piece of this, which you'll notice there's MQTT here. The reality is actually we've kind of tricked you a little bit. It's not MQTT versus OPC UA, it's MQTT and OPC UA. And what we mean by that is that there are very clear times where, in this case, this is our bridge from our local FlowFuse MQTT to HiveMQ MQTT. And then we're actually bringing in the HiveMQ to our FlowFuse remote device and writing to OPC UA. And we're doing all of our topic mapping in a function node. It's real simple, just saying, append to the namespace and go through this sort of functionality, define the data type. And if I want to do more functional complex things, OPC UA is there. If I just want reporting, there's absolutely no need for me to be pulling all of this data via OPC UA, right? Because it's exactly what Kudzai said earlier, that like OPC UA has its benefits, but it is very heavy. It is a complex thing to set up. It's heavy. I can show you in a few minutes the designer view of this. Like, it is a very complex thing to build, to deploy, and to operate. And so if what you're trying to do is just get data and insight, well, then why are you using OPC UA? That's like, unless you need all of the meta contextual data about every single individual piece, if all you need is a sensor reading, MQTT, 9 times out of 10. If you need to trigger devices, that starts to become a little bit more complicated. And I think with that, we should probably move into the next part of this, which is building for the future and forward thinking.
Just to sum it up, that this is obviously not a comparison to say you can only pick one. Like you said, it's kind of like more, and I'm sure the audience already is aware of this idea that there's certain use cases where you can use OPC UA, and then there's certain use cases where you can use MQTT. But this is meant just to bring that clarity on what we can use where. So to your point, again, distributing data, MQTT, but you still need to do that transactional processing where you are writing a recipe to a piece of equipment. You need to have OPC UA, or writing a command to a robotic arm. You need to know something like OPC UA. But if you're distributing data for analytics, you're distributing data for database visualization, dashboards, AI, and things like that, then you kind of like want to have something like MQTT that is more flexible and open.
And I think when we get to this last piece, which is the forward thinking part of it, we promised you an answer, right? We said, we'll answer this question for you. I think that there's some very clear use cases. I think when you're talking about connecting things that absolutely need to have a structured data model, something that has to have the structure and then also has to have the additional sort of the discovery of the data model and the transmission of that data model, like OPC UA is a great solution for sure, especially if you're in a brownfield environment that has OPC UA servers already in place, that has clients subscribing to it, they're interacting with it. As an OT engineer, if you have that reality and you're trying to decide, okay, should I rip and replace and go completely MQTT, or should I go OPC UA and scale it out? Like, I think your answer is pretty clear. And also there's the additional piece of it, which Kudzai mentioned earlier, which is the security side of it. MQTT also has some security pieces, but if you need something that is like a non-negotiable security layer, a chain of custody layer, regulatory frameworks, things that are really, really high needs in that particular domain, then OPC UA is like a pretty solid argument. But to Kudzai's point, when you're just moving data, when you're coordinating data, orchestrating systems, you don't, and when I say orchestrating, I mean orchestrating data systems, not orchestrating actions. When you're doing that piece of it, OPC UA is not the solve. Like, there's no need to have something so heavy and so complex to set up. I promised you a minute ago that I'd show you what this looks like in configuration, so I'll do that now. To actually get this thing configured and working, I told Kudzai this morning, setting up MQTT took me like maybe 15 minutes of getting the brokers talking to each other. Getting OPC UA set up requires you to go in and set up the topic structures, set up the namespace, go through and configure, if I want something to read write, I need to flag that. I need to flag the ability to record the history. If I am recording the history, I need to make sure, what's the max age of the data that I'm holding? What is am I including metadata in this? Am I reporting back quality? Am I doing like all of this has to be done? And although I will say that I set this up with scripting, and so you can import a script and have your OPC UA sort of set up good to go. That's still something you have to do. That's still something you have to know. A, know how to do, B, know how to write, and then C, know how to deploy. And when you just need something that is like simple, that is effective, that is widely used, everyone understands it. It is something across heterogeneous devices, really easy client-side implementation like MQTT is the way, 100%. But the reality, and Kudzai, you said this earlier, so I definitely like your thoughts on this as well. The reality is that like hybrid is the dominant strategy right now. It is not either or. It's not this or that. It is yes and.
Oh yeah, absolutely. I mean, I've always maintained for many cases for many years, because this debate has been going on for many years, that in many cases the debate is kind of like really unfounded, because the use case itself just answers it for you, right? So you're not going to go and rip things apart that took OPC UA on the shop floor and try to replace them with MQTT, and you're not going to try and distribute data to millions and millions of data points per second across your entire enterprise using OPC UA. So it's almost kind of like the use cases force you to actually use the right tool for the right job.
And then when you're thinking about all of what we've just said is literally just building for today. When you think about building for tomorrow, the reality is that like that hybrid piece of it is actually becoming more prominent, and even in the sense that like OPC UA has a part of the specification that is OPC UA over MQTT. And the variation of how to apply either of these technologies is almost always coming down to hybrid and to your deployment reality. So, for instance, how mature is your broker? That will determine whether you do OPCA over MQTT, whether you just do MQTT. Like if you're using a relatively non-mature broker, you're going to be limited in what you can do versus using something like HiveMQ or the native flow fuse broker, or an up-to-date solution is going to give you so much more flexibility. And then that question is no longer an easy answer, because the answer is, well, what do you want? What is your utility, right? And you start getting into, okay, unified namespace. Do you have a unified namespace? Because if you do, then an MQTT first architecture where everything is sort of like centrally aligned as a data source, and then OPC UA as a source connector and like work orchestrator, that is different than if you don't have a unified namespace at all. Because then your question isn't, should you use MQTT or OPC UA? Your question is, why don't you have a unified namespace, right? That's the question you should be answering. And I think like Kudzai, you and I have talked about this at length, this idea of like, there's legwork in either situation. Like the configuration, someone's going to have to do configuration. And so a lot of this answer is like, where are you in your journey? Are you actually ready to use any of this? Getting into the day after tomorrow, and I'll just go over this very briefly because we do want to get to Q&As. When you're talking about AI and ML at the edge, like that favors MQTT for sure, because you want as much data as you can locally as quickly as possible. Whereas if you're doing something that, requires semantic context in the long tail, it's not just being able to detect deviations in the data, it's detecting those deviations and then doing something about it. Then you start to talk about OPC UA as an additional on top of MQTT. And I think that is what we're really trying to advocate for here, is it's not an either or, it's a yes and. And so all of that being said, I'm going to move on to Q&A because we have talked all of your ears off. So we have from Luis, why not use OPC UA server as a central node like a broker and have everything else as an OPC UA client?
Kind of like, answered that. So first, it's the scale. How many, endpoints can you actually connect to an OPC UA server and distribute data? Secondly, it's not an open, ecosystem, as it were, because if you're going to expose data to IT, that is, OPC UA, and there's so many different tools that, don't really understand OPC UA to begin with, which is different, obviously, for MQTT JSON. This is widely adopted across many different tools. Number three is the complexity. Again, I think it's one and the same thing as far as the open ecosystem is concerned, right? Where you're able to sort of like, pick any tool that supports MQTT and solve a specific problem, and then sort of like move on from there. So kind of like touch a bit on that, but
I think also, again, it's just very different use cases. I think ultimately your answer there is going to be defined by what you're trying to do. That is the sum total. I think the sum total of our entire theory here. And speaking to that, Tushar has a question. When we define a contextualization tagging across assets, sol to site, etc., does OPC UA support that, or do we do already as we do with MQTT? Should we continue doing that, or is there any way we can do that even in OPC UA? So here's the thing, and we sort of hinted at this when we were talking about the legwork piece of this. MQTT absolutely is a fantastic way to add contextualization. You can add that. The problem is that you have to add that in stream for everything that you're writing out. And so to emit context about a thing, you have to send that message along with it. Like if you're not saying that message, if you're just sending a null value, you're not going to get that thing. You have to fall back on historical things. With OPC UA, by definition, that is part of the data that goes out at all times when you've set that, for better or for worse. So the good thing is that that context changes on the MQTT side of it. You can just write that out with MQTT. And in fact, I'll pass to Kudzai after this to validate that. But like on OPC UA, the good part about it is the first time that you set up that data context, it exists with that data forever. Fantastic, right? The bad thing about it is it exists with it forever. So if you have to change something, you have to purposefully go in, you have to change your configuration, redesign it, and then you have to figure out what that means for you for your historical data collection.
Yep, 100%. I think that's spot on, because with OPC UA, you're effectively, defining a node set, file that represents your address space. So you define that if you're building a machine, you define that once and ship it with the machine. If you are building it in your server, you're defining that and shipping it with the server, and then it kind of like represents that. It's not dynamic, right? So with MQTT, I can purchase a PLC, connect it up, and start publishing data or additional context to that broker without having to go and change the node set, file address space and things like that.
Adrian says, we do smart cities integration and having to navigate OTIT spaces. We come across both MQTT and OPC UA. OPC UA mainly at the edge covering SCADA systems. The question is, from all the diverse systems, we have 3 data streams: real-time on-demand data, alarms, events, and historical data. What ways exist to handle these 3 different streams in MQTT and OPC UA? Which sort of bookends a little bit to what we were just talking about. I'll give you the OPC UA answer, which is that as long as you set as long as you design the actual structure of this ahead of time, and then you have them reporting via the same OPC UA server or the same sort of structure, any client that connects to that OPC UA server and has the permissions to read that can access those, can combine them, can do whatever they want with them. That, at least from the OPC UA side, is the answer. The problem is that the legwork to actually get that working is sort of not justified by some of the cases that you just suggested. So for instance, alarms, events, asynchronous, specifically alarms and events. If we're just doing reporting, in my mind, and I'm not going to speak for Kudzai, but at least for me, I think that's an MQTT solve. That is, you need the thing to push, you need to say, this is the state of the thing. That's easy. When you're talking about something that is on-demand data, I need to get a graphical view of something, and you're just extracting data out. Perfect MQTT, perfect, do that. Historical data is served through OPC UA as a default data type. You can turn that on and get history and write to anything. Whereas with MQTT, you would have to have like a database to write that. You sort of do for OPC UA as well, but a lot of OPC UA solutions have a built-in database. So Kudzai, I'll pass to you for the MQTT side of that, specifically about the handling all of those data streams in MQTT.
Yeah, I mean, I think you summed it up, pretty well there. Real-time on-demand, MQTT, alarms and events, MQTT. So basically, you are really, converting all of that. We've got, some converters that allow you to grab alarms and events from OPC UA. Those native alarms, push them MQTT. Data access OPC UA, push it into MQTT. Or in some cases, even access, OPC UA historical access, the historical data, do whatever transformation or aggregation, push it into an MQTT as a snapshot. So
yeah. Now, Hasse asks, I hope I pronounced that right. Hasse asks, in the case presented in the OPC UA requirement, is that actually a technical necessity or is it a regulatory artifact of being in pharma or life science? If we could live with the occasional burp, say a dropped reading here and there, would an MQTT always be good enough? I think don't get hung up so much on the fact that it's pharma life science, get hung up on the implementation of what it's doing. If our requirement was just to get the data out, then MQTT is the way, 100%. That is super easy, super lightweight, super efficient. I would go MQTT 100% of the time. What we're doing in the implementation with OPC UA actually is getting the thing out and then doing a determinative action that writes back directly to the device. That doesn't go through any middleware, doesn't go through like okay, we're going to report the state, and now because of the state, we're going to trigger this thing. Like, we want to have A to B to C. That is the OPC UA of it. And in that case, like, we're not okay with a good enough burp in the data. We're not happy with that because we have to immediately, it's sort of like a safety stop, right? We have to immediately kill the thing. We have to immediately act. In that case, OPC UA is a requirement. So we're running out of time now. I see there's a bunch of additional questions, additional Q&A requests. What I'm going to go ahead and do is answer those directly in a follow-up. We'll go ahead and record all of these. But for now, I want to let you all know this was a fantastic session. I really appreciated you all attending. If you'd like to reach out to talk to us about any of your projects and how Flowfuse can help, just say so in the survey or use our contact form on flowfuse.com. Definitely go check out HiveMQ as well. Kudzai, I really appreciate your time today. Great talking to you about all of this. And we'll see you in our future webinars. We have some incredibly dense protocol webinars coming up. So yeah, until the next deploy. Thank you, everybody.